Okay, good afternoon, ladies and gentlemen of Precalculus. We're going to work on problems 33 and 34, half-life problems. The half-life of a certain radioactive substance is 14 days, and there are 6.6 grams initially. And this takes a half-life equation, has this form, and it's this. Your amount, I'm going to call amount A, equals our starting amount times 1/2 to the power of time divided by our half-life. So that's going to be just our basic half-life formula equation. And so we can substitute in to see what happens. This is in the place our initial amount. And so we can go ahead and plug in. We have A, I'll call it A of t, is going to be equal to 6.6 times 1/2 to the power of t over our half-life of the substance is 14. So that's a function we can use to find this out. And this is our answer to part A. Okay? Does that make a little bit of sense? And this ties in with some of the equation variations we've looked at up till now as well. Okay. Now for B, when will there be less than 1 gram remaining? How would you do that? What would be your strategy for that?
Put 1 gram as AT.
Yeah. When this becomes, how would you find that?
Add it in.
To put 1 in here?
Yeah.
So 1 equals 6.6. Now we're looking at part B, right? 1 equals 6.6 times 1/2 to the power of t over 14. Okay, what next?
Solve it.
How would you solve it? That's kind of what the question was.
Got me there, G.
What would be your ways of solving this? I'm going to show you a couple ways of doing it. How would you solve this equation?
Divide by 6.6.
Okay, if we divide by 6.6, right? And so what Nicole's doing, she's kind of taking us down the rabbit hole of a logarithmic solution, right? Which is a valid solution. So now we have, I'm just going to bring this up here, we have 1/2 to the power of t over 14 equals 1 over 6.6. What next? We talked about it yesterday. How do we isolate this t up here as an exponent? What operation cancels an exponent?
Square root.
No? From we talked about yesterday, it's a logarithm. A logarithm. So what we have here, didn't we talk about that yesterday?
I remember that.
You don't remember that?
I don't remember it.
You don't? Karina, you remember us talking about logarithms yesterday?
Yeah.
A little bit. Yeah, we talked about it a little bit. We talked about more in 6th period, I guess. Anyway, what you have is this is a base, and this is your exponent's place. And so what a logarithm is this number to the power of what equals that. And so to rearrange this exponential function as a logarithmic equation, we're going to have log base 1/2 of 1 over 6.6 is going to be equal to t over 14. And so t is going to be equal to 14, multiplying 14, log base 1/2 of 1 over 6.6. And we can go to our calculator and find that out. And where do we go for a log base? Go to math, and we go to math A. And I'm going to press alpha A to get there. Log base, and we can put 1/2 right there. And I forgot to multiply by 14, right? But I'll multiply by 14 after the fact. How's that? And then we have 1. Let's see, I think it's this. Yeah, 1 over 6.6, right? And then we had it also, it's going to be times 14. Was that all there was to it? I think so. So 38.
How did you get there? Like, how did you do it on the calculator?
Okay, went to math, and then you go down to A,
Oh.
log base. So that's how you get there, okay? Let's get back here. So 38.11. So 38.11, that'll be days. Now, there's another way to do, there are other ways to do this with a calculator that probably are easier than this, and I will show you, okay? Nobody's going to complain if I show them. Okay, come right here. I'm going to say 6.6 times 1/2 to the power of x over 14. Okay, and then if we go to zoom 6, we see this arrangement here, and we want to find the number of days it takes to get to 1. Well, we can have the second equation of 1, but to see that intersection point, I know I'm going to have to go out to a lot of days. I'm going to go to 40 days. And then we graph, and what we have is an intersection point out here. And find the intersection point, second trace 5, enter, enter, enter. And what number do we see here? 38.11. Okay? Or, like we've done in the past, you go to table view as well, right? And see when we come to, well, I have that in months. Let me change my table start here. I'm going to go to 35 by ones. Okay, we go to table view. We can see here that at 38 days is when, after 38 days, we're going below 1. See that? So a lot of different ways of doing this.
Can you stay right here for a second?
And what I want to do for a similar problem, the next one, is I want to go to our wheel. I'm going to choose people. And open. And here's what we're going to do for this one. If I could spell Nicole, that'd be great. So there it is, right?
Yep.
Okay. So I'm going to go ahead. I want you to do the next one. I think it's 34. Let me erase this one. 34 is the same type of problem, right? What you're working on. There we go. So I would pick somebody for that. I'm going to do a hunt first. Some papers. Yeah, I think you missed like starting 3.1 on. Here we go. Yeah, I got them right here, most of them. Got it all here. I think these are the ones here.
I have a list of everything I didn't do.
Okay, well,
2.8 up.
you didn't do 2.8, okay. These are the three ones. I'll get the 2.8 stuff too. Okay. 2.8. These are a couple 2.8ers.
I just did exercises 1 through 6 instead of through 12.
Yeah, this is it.
Okay.
I think that should be it, really. I'm going to choose spin the wheel here for this one. Okay, let me go shuffle a little bit. Karina, this thing picks Karina a lot, it seems. That's okay. She's ready for it. Okay, Karina, what do we got here?
Is t equals 3.5 times 1/2 to the power of t over 65?
5 times 1/2 to the power of t over 65. Okay. So that's part A. And then part B is
After 117 days.
after 117 days.
Yeah.
How did you solve this one?
I looked in the table and graphed it.
So you did you look at the table
Yeah, and then I did the graph.
and the graph too? Okay. Well, let's do the graph because I think the graph's a little faster. And we see it's 1 gram remaining. So 3.5 times 1/2 to t over 65. And then she says that she said it was 117, so I'm gonna make sure I have enough room for that. I put 150 by 10s. That should be it, right? Graph. So we get second trace 5. Enter, enter, enter. Yeah, so it's 117 days.
That's
Okay.
what I got too.
Right, okay, good. Good work right there. And after this exercise set, we're going to peel off and work on some more half-life equations. So I'm going to do that work for you. So I'll pick that up. Let me give you some half-life work to start doing today.
I'll try and finish all this by Friday.
Yeah, I know you'll be good at it. Where's my half-life stuff? Here it is. Okay. Here we are. Here. So this first problem here, problem 1, I can start calling on people now, or do the first one, or I don't know, what do you want me to do?
You do the first one.
Okay. I'll do the first one.
Is it the same thing?
Yeah.
It really is the same thing. So this is additional reinforcement. So this is not from the book. Okay, these are some extra problems. So let's go to the right file here. Here it is. So solve each problem. You have 10 grams of curium-245, which has a half-life of 9,300 years. How many grams will remain after 37,200 years? Well, it's going to be the same type of thing. A, so T, equals our initial amount, which is going to be 10 grams. And then we have times 1/2 to the power of T over 9,300. And one thing that you have here going on is this is one you can actually do without a calculator, because if we have for T equals 37,200, you can say T over half-life is going to be equal to 37,200 over 9,300. And what's that going to be? It'll be a nice integer number.
4.
It'll be 4. So our answer is going to be 10 times 1/2 to the 4th power, and which is going to be equal to 10 times 1 over 2 to the 4th power, and that's going to be equals 10 times 1/16. And so that's going to be 10 divided by 16 equals 5/8. So 5/8 grams. And if you did this in the calculator, you had 0.625. Is that what you got?
Yes.
0.625. So that's a way you could do that problem, even without a calculator. Okay? And obviously with a calculator too. All right, I'll choose somebody for number 2. Number 2, we have but you, Nicole. All right, man. Beginner's luck on a new day. All right. She's ready for it, though, I know. Okay, what do we got for number 2 here?
I can do it. That was easy.
I think I know. I think I could do this one in my head.
I already got 8.
I think I know what this is in my head. It's 4. I think I know where it is.
10 grams.
10 grams.
Yeah, is that not right?
How'd you get 10 grams?
I divided 213 by 71 and got 3. And then I multiplied 80 by 1/8.
Times 1/2.
Or 10 days, whatever. I don't know.
To the power of 3, right?
Yeah,
Which is going to be
1/8.
80 times 1/8, which equals 10
Yeah.
grams. Okay, 10 grams, all right. Questions on that one? Pretty simple. Maybe a little sticker here. Helps add to the points.
Appreciate it.
Great points. All right. Okay, number 3. Okay, so we have number 3 here. That's going to be Justin didn't make it today. So he's out. We're left with everybody else. Elizabeth, all right. Got number 3, Elizabeth.
Oh, man.
Okay, what do we have for that?
The equation we're going to get is 7,500 times 1/2 to the power of x over 1.5.
Okay,
And then the amount that you'll have remaining after 30 days is going to be 0.00715
so A of 30 is going to be, what did you say it was?
0.00715
Does that look right?
Yeah.
Yeah, I think it really, because this is going to end up being to the 15th power, which is really going to make this divide a lot. That's 0.00715 grams, all right? Okay. I think that 4 and 5 are pretty similar. 6 is a little different here. I'll pick somebody for, oops, that's 4. That's 5, right? Let's see if I got 4 here. Whoa, where's 4? What do we do to 4? All right.
On the back.
You have it on your paper, right? I don't have it up here is what I'm saying.
Oh, okay.
So here's what I'm going to do for this one. I'll say, okay, 1, that's going to be cesium-137. Half-life is equal to 30 years. And that's going to be grams. And how much after $200 years, right? Which is today, but that's context of the problem. Okay, I'll spin the wheel on that one here. see who we have here for this. Not a lot of choices left here. Becky, so that's just you here. What did you get for this one?
I'm still working it out.
Okay.
I put A equals 132,000 times 1/2 T over 30.
Okay.
And then do the same equation, but you put 200 as T.
200 is T, okay. So A of 200. And what'd you get for that?
Um, it's one, I just put in the calculator, I got 1,299.
Grams.
29.
What did you get?
It just divide. It's just 1,299.29.
4.29.
Did I shorten this because I just shortened it?
Okay,
Make
yeah.
it smaller.
0.29 grams, right? Everybody else get that?
No,
No?
I don't remember that.
Okay, let's do that. I want to put this calculator.
At first I didn't have.
So 132,000 times 1/2 to the power of, we have 200 years divided by a half-life of 30, right? This is it, isn't it? Looks, guess what Becky got, right? So I'm pretty sure that's a good answer right there. Okay. Let me pick out number.
Oh, that's not what I got. Can you see what I did wrong?
Oh, let's see what you did wrong.
That's my word.
Okay, yeah, you did it as a logarithm. You made it more complicated than it needed to be. What's the next one? Here, let me show you.
But shouldn't we got the same thing anyways?
No, because what's going to happen is you're going to solve for t maybe, but you don't have to. You just plug this in right here.
Oh, you just plug that part
You
in.
plug in 200 for t,
Okay.
and then you have what that answer is.
Oh,
Okay?
so you. Okay, I got you. Never mind.
And so in the calculator, this is what it looks like in the calculator. Okay. All right. Okay, next. 5. And I'm going to go ahead and save this one so I'll have at least that problem right there. Cannot be found. No, I can't do that because it's in the wrong file.
Becky, what was
Got
the
it from the
answer?
wrong place.
12.99.
Okay.
Yeah, 0.29 grams. 0.29.
Okay, number 5. Spin that wheel there. know it's gonna be Robert. Okay, Robert. Stick it here. Okay. Okay, Robert, what'd you get for this one?
I just got 0.
You got 0?
Yeah, the answer.
No, I got 6.899.
Why would I do this wrong? T over 224.
1 million years, so it'd be like 1 million.
Over 24,400.
You can cancel off the zeros,
So you can cancel
and
out
then you can divide it.
these zeros.
And you get 2,500 over 61.
Yeah, I didn't do that.
Okay, yeah. But when you put this in the calculator, you get 150 times 0.5 to the power of, oh,
I tried it both ways and didn't get it when you divide. I have a division sign, so.
1 over 24,400, was it? So you should get this. Is that what you got?
Did, yeah.
Is that what you got?
No, I didn't.
I just shortened it and put 6.899.
It doesn't matter if you put in like
Okay.
1/2 instead of 0.5.
No. So this is going to be 6.9
Here, I don't know.
times 10 to the negative 11th power times 10 to the negative 11th power. You know what that is? You know what to the negative 11th power is?
Isn't that more?
Yeah, well, they deal with the small negative exponents, but what it is 1 millionth is 10 to the negative 6th power, right? 1 billionth is 10 to the negative 9th power, and 1 trillionth is 10 to the negative 12th power. So this is going to be 69 times 10 to the negative 12th power, which equals 69 trillionths. Of a gram. You understand those numbers, those real small tiny exponents from chemistry and all that? Does that make sense to you? All that? Okay, good. Okay, 69 trillionths of a gram, very small. But the thing about radioactive dating, they can actually detect very tiny amounts of radioactive substance with Geiger counters to figure out what's going on.
So Luigi.
I have no idea what I did wrong.
Let me see.
Yeah, so anyway, next, we're sort of out here, so probably tomorrow. I know, Riley, we didn't quite get to you today. Are you disappointed, Riley? You want to do this one tomorrow? Not really. This is one that is a little bit
Too many
different.
zeros.
This one is a little bit different, but we'll talk about that
Yeah,
tomorrow.
I can't.
I figured out why I got it wrong.
Yeah.
I had put too many zeros in 1 million.
Oh, really?
Yeah.
Okay, yeah.